Hello, this video is for the question 2, also in the tutorial 3. So question 2 is about a closed system, contains a mass of 5 kg. So basically this is a fixed mass for a closed system, and the system undergoes a process during which 130 kJ of heat is transferred from the system. So we can see that's from the system to the surroundings. Okay, as we can see here, as I mentioned in the lecture, so we can compare the way the system is working here with the way an engine is working. Okay, so if it's different, then it got the value of negative. If it's the same, and it got the value of the positive. So you can see here, the heat transferred from the system to the surroundings. So this is the opposite way of an engine is working, because the engine receives heat and the heat is transferred to the system. So here we know that the heat Q is equal to negative. As I said, this is the opposite way of an engine is working. And also here we have 65 kJ work is done by the system on the surroundings. So now you can see here, this is the same way as the engine is working. So we have a positive value for the work. So this is 65 kJ. Okay, and also we know here the mass is 5 kg. Okay, so we can just list all the information we extracted from the question. So here we can see that we have the change in the kinetic energy, and also the potential energy is 0. So this is actually why we're going to use the first law of thermodynamics, this equation in here, because this is a change in U, not a change in E. That's because we already neglected the change in the potential energy and also the kinetic energy. So we're going to use this equation. And so we know the initial specific energy. Okay, so you can see here we have a specific, which means that we'll always use the lowercase for that, so you need to be very careful. And also you can see here the unit. Okay, also be careful of the unit. So the unit itself actually tells us it is actually a specific term, because it's per kilogram. So this internal energy, okay, so we have U, as I said, is lowercase u. So U1 is equal to 435 kJ per kilogram. So what we're going to calculate is the final specific energy of the system. So final, we always use the second point for the final point. Okay, so we're going to calculate that. Okay, as I said, we're going to use the equation here, which is applied to any closed system for any process. Okay, so now I'm just going to write that equation first of all, so which gives us 1 to 2 during this process, the heat transfer subtract the work transfer, which is equal to U2 subtract U1. Okay, so you need to be very careful. Actually here you can see that these internal energy are written in a capital word. Okay, however, these values are in specific terms. Okay, so we need to convert that to specific. Basically, we need to multiply by U. Okay, so that's because any specific form is defined by the capital letter divided by M. Okay, so you can see the capital U is equal to M times the lowercase u. Okay, so now we can see that we actually have got the Q, we have W, okay, we have M, we have U1, and we need to calculate U2. Okay, so there's only one unknown here, so we just need to rearrange them. Okay, so I'm going to probably just divide M on both sides and then move U1, so we have U2 left. Okay, so now we have U2 is equal to move U1 over here, add Q subtract W divided by M. Okay, so U1 gives us 435 plus Q, so be careful, that's minus 130, subtract 65 divided by M, which is 5. Okay, and then we can calculate that, which gives us the final answer of 396 kilojoule per kilogram. Okay, so always need to remember that for your final answer, you need to put the right unit behind the figures. Okay, so that's the solution for question 2.